Hello, everyone, and welcome to Application Development with ASP.NET, episode number 9, with your host, Mr. Nelson LeKay. Hey, Nelson.
Hey.
Hey, and Zach Parrish.
Hey, how's it going?
Myself, Jason Busby. Now, if everyone recalls, for those of you that's been following along with these episodes, we are working on a project management system. And it was in the last episode in which the base foundation was started. A few episodes before that, we spent a little bit of time talking about some of the technologies that we would be using. And in the last episode, we did some coding and we basically started the project. Now, for those of you that join us on the 3D Buzz radio shows and from time to time take a look at some of the things we may post in the forums and over in Facebook and Twitter, you may have caught where we were talking about this project management system being a little bit larger scale than just something simple that will accommodate our needs through the MMO project. As a matter of fact, we're looking at this more so almost from an enterprise level to where we could accommodate businesses if we wanted to. And we're going to start by just giving member sponsors the ability to have their own projects that they can set up and manage as they're following along with the MMO class. And we're going to be using the exact same system. What's great about that is we're going to be able to receive feedback from all of you member sponsors out there as to features that might be really handy to add in to the system. So very exciting. But the thing is, we're looking at an application that has the potential to become very large and very complex. Now we're going to try to keep things, as steps, building steps, where we're just going to add small features so we can, get out the gate and start using something quickly. At least, Zach and Nelson, myself, Lee, but with the potential of taking this where we'd like to go. Nelson did a lot of thinking and came back to me and said, "Look, if you have no objection, I'd like to lay the framework out just a little bit different since we're still pretty much at the very beginning." This is a bit more solid. I've been thinking about it as opposed to just doing it right there on the fly, which is really what we do in all of these episodes. And I told him, we just started out, so I'm completely cool with that. Now there's going to be some new stuff that Nelson wants to talk about. And so we're going to have, instead of just start coding the entire thing out right now, I think we're going to use the next couple of videos to talk about some of the new stuff that Nelson will be using and then coding it up. Am I correct with that, Nelson?
Well, not so much as new stuff, but we're going to be using some more advanced features of Autofac, for example.
Yeah, well, new stuff as in Fluent and Hibernate's what came to mind as I was just rambling that off. So that's kind of new. But anyways, go ahead. Some more advanced features, which is stuff we haven't covered, making it new stuff. But continue.
and then in addition to that, we're going to be looking at Fluent and Hibernate. You'll remember that I had an objection to using Fluent and Hibernate initially. Mm-hmm. But unfortunately,
you were wrong.
I wasn't wrong. From a teaching perspective, doing the XML mappings is very good to get a solid foundation of what the mappings actually do. From a productivity and maintainability standpoint,
you were wrong.
XML mappings are a bit more difficult to use because there are a lot of extra redundant code, and when you're worried about especially maintainability and productivity, you want to make sure that there's not very much redundant code. Mm-hmm. And Fluent and Hibernate, combined with its auto mappings, allows us to define things really quickly and really flexibly. And we're going to be going over how to use that in the next video or so. But
okay,
cool.
Yeah. Well, am I going?
Yeah.
Yeah, dude, go.
Okay. So first, we're going to talk about Autofac, and it's kind of lagging here. Well, actually, I just realized this. Instead of pulling down Autofac from the thing we've already downloaded, I'm going to go ahead and use NuGet just to grab Autofac really quickly. NuGet is a new. So you see that NuGet is a project management or package library solution for .NET, completely open source, accepts contributors, and it's backed by Microsoft and integrated very tightly with Visual Studio. It's very new, and we see that Autofac is available for us, the version that we want, and we just hit install, and it downloads it and adds it, and that's really cool.
Very cool.
Unfortunately for our project management system, we're not going to be able to use NuGet because it doesn't have some of the packages we need, and it doesn't put its libraries in a folder that I particularly like. But for this video, it was just kind of cool to just grab Autofac really quickly.
Yeah, nifty.
So, and if you're wondering, there's a it dumps it in a local folder called packages. So you see the Autofacts right there with the lib.net for autofact.dll.
Very nice.
So all we need is Autofac. We're not going to be doing Autofact.configuration, nor are we going to be referencing in our applications. And the difference between Autofac and Autofact.configuration is .configuration lets us override our Autofac configuration with XML files so that we can change our components at runtime. But because we don't need that feature yet, I'm just not going to use that that library. So I'm just going to reference Autofac. I generally like to keep as few libraries as possible referenced in an application. And because we're not using them, might as well not have it. So we already talked about So Autofact starts off with the container builder.
Mm-hmm.
And the container builder provides a lot of awesome ways to register components. Remember that we talked about IOC. I'm not going to get back into what IOC is good for or anything. This is purely about Autofac. If you want to learn about IOC, just watch the previous episode. I believe the previous episode.
Sure, but the whole idea is that we want to use this dependency injection, the inversion of control, where we're basically going to be able to register a bunch of components, and we will let our container basically figure out what components things are going to need.
Exactly. So here's our container builder. I'm just going to call this builder. And then once we've configured the builder, we're going to build a container with the builder.build, which creates a container. Have you ever talked about this particular syntax before, Jason?
I'm sure we did and I know we did in the XNA class, one of the Volume 2 or Volume 3 videos. But go ahead and talk about it now, just for those that have not seen that because they didn't go through the XNA course.
Okay, well, this code right here is equivalent to actually, it's not. Then I'm going to comment this out, so I'm just going to nuke it. Or, no, I'm going to comment it out. So this code right here is equivalent. The thing about, so try finally, everyone knows try catch, right?
Mm-hmm.
Try finally is where finally will always be executed whether or not there is an exception thrown, which is cool because it also applies to methods that return. So for example, if I were to return right here, this finally block will still execute.
Mm-hmm.
So what that allows us to do is it allows us to call the dispose method, and you'll notice that's idisposable.dispose, and you'll notice that container, not container builder, but I don't have a container. Oh, here we go. You'll notice that it implements the idisposable interface, and the idisposable interface is a convention in the .NET framework that says that if any class implements the idisposable method, when you're done with it, you have to call the dispose method. And that's really just a convention that it's not really enforced by anyone. It's just you have to do it. And it's used for cleaning up resources. And that's a very, very, very important concept of what we're going to be talking about here, because how Autofac manages disposable resources is incredibly important when we start working with Hibernate, where we have to create a session on every request and then dispose the session on every request. So we need to know how Autofac deals with this disposable. But Autofac itself is disposable because whenever we create this container, we want at some point for it to be disposed. Well, I take that back. And this example is trivial because at the end of this we're just returning right here. We return out of the application is done. We don't really need to dispose it, but I'm just using the syntax to demonstrate that when I am using the syntax, what's happening behind the scenes is that whatever variable we initialize right here, or even if we don't initialize any variable, if it's just an expression that returns an iDisposable, then that value then gets disposed at the end of this using statement.
Okay.
Yeah. So now we can do stuff with the container, and the stuff that we can do is determined by what is available on this object. The most important ones are the resolve. The resolve method in Autofac is what we use to pull out services. And let me go ahead and define what a service is. In Autofac, we register components to services. Components are the concrete classes. Services are the interfaces that we want to deal with. So right now we could resolve, but there's nothing we can resolve to because we haven't configured Autofac with any. We can't resolve any service because we haven't told it about any services or any components. So let's go ahead and create a component real fast. Let's call this the console printer component. And that's the component, but we also obviously need to define his interface, what service this component exposes, and that's going to be the iText printer. It's going to be the component. So remember how we talked about if pieces of our code are dependent on this iText printer, we only want to have to ever reference the iText printer. We're never going to want to deal with the console printer, and that's exactly what Autofact's for. Mm-hmm. So we're going to define this interface with a print method. And then we're going to implement this interface with the console printer, which obviously requires us to implement the print method. Mm-hmm. And he's just going to do console.writeLine message. So now at this point we want to get a printer in our main method. So we want to do printer equals container resolve iText printer, and we want to print a message. Printer.print. Unfortunately, this won't work because we haven't told Autofac which concrete class to use whenever we ask for the iText printer. So let's go ahead and do that now. Let's do builder, register type, then our component, which is going to be console printer. And then, I'm actually going to break this out like that. And then we're going to say as, and then our service. And then end that. And basically what this is instructing Autofac is it's saying whenever someone asks for the iText printer service, we want to give them a console printer. So we can go ahead and say console read key, and we're done.
Cool. Very
nice.
So
that's really cool. But we need to extend this a little bit further because this is particularly trivial example. People might ask, well, why can't you just say var printer equals new console printer? So we're going to have a application or a thing or a, I don't know. We're going to have a something controller. Zach, name.
Yeah, I have no idea, man. Sorry. You're on your own.
We have a bar controller.
Okay, we have a bar controller. And our bar controller, in order to operate, needs a text printer. And then he's going to have he's going to store his text printer in a private field. And then he's going to have a method called display people in bar. And he's going to say printer.print person 1, person 2, person 3, person 4. Okay. So there's our bar controller. Now he has a dependency on a service, on the iText printer service.
But he has no actual dependency on the console printer.
No, but he has a dependency on the
absolutely. But that's again that's the whole idea with the inversion of control. Our concrete class, we're not dependent on it, which is really nice because as long as whatever concrete class implements the interface iText printer, we could have our container inject whichever one. Bar controller would never need to be changed. It knows how to work because it's using an interface that's going to guarantee a contract.
Right, and that contract at this point is just a print method.
Exactly.
Mm-hmm. So we want to now instantiate a bar controller and then have Autofac automatically pick up on all the services he depends on. So to do this, we need to tell Autofac about our component. So we're going to register another type, bar controller, and then we're going to say as self, and that's it. And as self means that basically as self is actually just a shorthand for this, if that makes sense, to where we're defining the component and the interface as or the component and the service as being the same thing.
Mm-hmm.
But we can do as self as a little shorthand for that. So now instead of doing this, we can say, I'm going to go and nuke this. I'm going to say var controller equals container dot resolve bar controller dot display people in bar.
And what's super cool about this, because this really starts to kind of bring home the importance of an IOC container and how cool it is we know that when instantiating the bar controller, it has, if you scroll back up a little, Nelson, thank you, sir, that it has a constructor that's looking for that interface, that iText printer. But you'll notice we didn't have to actually instantiate any kind of implementation of iText printer and hand it off to the bar controller. The builder, our container, worked all that out for us, which is awesome.
Yep, and that's that's the basics, and we pretty much already talked about that.
Sure, it's a good review though.
Right.
Zach, how are you doing? Is it making sense?
So.
So? Okay.
Is there anything I could do to make it more sense?
Not right now, no.
Some massage oil, make him a margarita.
This is not that kind of video.
Do his shoulders. Oh, I'm just, ease you up a little, Zach. Ease you up. The cool thing is the fact that our container, I mean, we do understand that without even looking or thinking about the container, but make sure this makes sense. The fact that we have an interface, and then we have a concrete class that implements it.
Right.
Then we have another very simple class that just holds a reference to some sort of implementation of iText printer. Mm-hmm. So it just happens that our console printer implements that, so we're in good shape there, so we can hold a reference to a concrete iText printer, being console printer in this case. And then we have just a regular old constructor that, and this is what I love about constructor injection, is there's no way that we could instantiate a bar controller and accidentally not inject a dependency that's needed. So we call this constructor. We have to provide a concrete implementation of iText printer. So that makes sense, right? So we instantiate this object. We have to give it an instantiation, in this case, of console printer. And then the class just has, another method in it for displaying people in the bar. Now, down here, this is where it gets really cool. Using Autofact, we create this builder, our container, and then we need to register our services and our components. And so we register the console printer, and we register it as itself. We register, I'm sorry, hang on. These almost should have been flipped around just to make it easier in a smooth flowing explanation, but it doesn't matter. We register the bar controller as itself. We register the console printer, which is the component. It's a concrete implementation of an iText printer. So we know that, or the container will know that if something needs an iText printer, we can give them that. Okay, so now with Builder, since we registered the bar controller as the bar controller, our container is smart enough to know that it needs to look into bar controller and find out what does it need to provide it to be able to instantiate, to actually create a bar controller object. So it sees in the constructor. Do what, Nelson?
Well, I was just going to do one quick thing.
Yeah.
I was just going to comment this out and show what happens, just to prove that it is Autofac doing that. Well,
I figured it would be good, just the fact that you didn't actually have the code in there yourself, but okay.
So none of the constructors found. So yeah, just like Jason was saying, now Autofac is not smart enough to resolve this dependency. Mm-hmm. But okay, so that was just at the side.
Yeah, no, that's cool. So basically, when we get down here and we say that, look, container resolve a bar controller because we need one, our container Autofact says, all right, well, we need to make an implementation of a bar controller. We've looked into bar controller and we know what bar controller needs by looking at its constructor, and we know, as the container, we know what an iText printer is because that's been registered. So it instantiates the concrete implementation of that. So it instantiates a console printer and injects that through the constructor into our bar controller. So now we actually have a bar controller that's been instantiated properly because we fulfilled its constructor requirements, and then now we can just go about using it like normal. And this is still may look very convoluted to people who've never worked with dependency injection or the whole concept of an inversion of control, because you're thinking, wow, look at all this extra stuff, and why couldn't you have just simply had a line that said var controller equals, and then we create a new bar controller and feed it in an instance of a new console printer? Well, sure, but this is when you start using the IOC methodology, you're generally dealing, or you're going to be dealing with much larger scale applications. And what ends up happening is this actually will begin really simplifying everything as we keep all of our components decoupled, so that we don't create dependency issues all over the darn place, which adds to flexibility and expanding the application.
Right, we covered that all in the IOC
Absolutely.
discussion.
So it's just kind of just a quick walkthrough, but showing how the actual container here is doing the work, how it was smart enough to know to resolve getting a bar controller back and having that bar controller properly instantiated, meaning its constructor needed some sort of iText printer. So it instantiated one, shoved it in there, created the guy, handed it back, and said, go ahead, use it. So it's cool that our container worked all of that out magically behind the scene for us. Was that an okay explanation for you, Nelson?
Yeah.
For people? Okay, cool. Okay, so there's just another overview. So continue from here. It's very cool stuff. I love it.
Yeah. Well, okay, so register type, that's just one of the ways to do it. We're also going to be talking about just the register method, and we're going to be talking about the register generic method, because those are the ones that we're going to be dealing with in the project. So the register method is just another way to register a dependency. So let's say that I have a something. Trying to think. Let's say I have another service called, I don't know, an interface iText getter. And then I have another console getter. Console text getter. iText getter. Turn console read line. Okay, so we're not going to be using the register type. We're going to be using something a bit different. We're going to use the register method to register this particular component. The register method is really cool because it takes in a delegate, and you'll see that right here. It takes in a delegate that passes in an iComponent context and then returns a T being whatever component that we are registering. So we're going to do that, and then let's just do new console text printer, or text getter, and then as iText getter. So this really, right now, it accomplishes the same thing. Register and register type accomplishes the same thing. But what's cool about it is that now that we're in this Lambda, we could pass in anything that we want. We could pass in a reference to a property. We can pass in anything. And then we can also pass in constructor arguments into our component. So for example, if our console text getter requires a string called, let's say, prefix, or our, prompt. He takes in a string prompt, and then before he reads the line, he gets data from, or he prints out prompt. So at this point, we can now use the register method to pass in information into the constructor, and then it gets registered as an iTextGetter. So this delegate then gets invoked every time an iTextGetter is requested, and then the result of that delegate gets sent into the rest of the dependencies. So for example, if our bar controller now depended on an iTextGetter, we could say getter, I don't know, var stuff equals getter. I don't know what I'm doing. Something like that. Getter dot get text. And then now we can run it, and we'll see that our implementation works properly. So the first thing we'll do is we'll get a prompt, and then I'll type in some data, and then that'll happen like that. Yeah. So that's one of the other ways to register a component. So we can put arbitrary code in here, which is the cool part.
But it's still it's super cool, because not just arbitrary code, but it's still working out something that console text getter needs. Huh? Hang on. Do. Oh wait, never mind. Continue on. I was about to branch off in a different direction. Ignore me.
So you might be asking here, how do we pass dependencies into console text getter? Do you know? I mean, yeah. I don't know why anyone asked that.
What I was meaning to say a second ago, I jumped over to the one I was referring to the bar controller. The fact that it still controller
right.
still worked. It still worked out, even though we just changed its signature and everything. We didn't have to go back and change, other code.
Yeah, exactly.
That's what I was. But I got so caught up in all the new text thing you just added. But that's what I was trying to point out, is we didn't have to go change code elsewhere. You just changed the implementation, and since there was already a service registered to handle that, we didn't have to change anything else. It just worked.
Yeah, so that's the beautiful thing about it.
Exactly.
Because now whatever bar controller needs to work is determined by bar controller and no one else.
Mm-hmm.
So yeah, so if console text getter required some sort of dependency, and I'm going to have, so you notice that we have this prompt, but that's not very good. We need to do our iText printer. We need to use our iText printer to print the prompt, because that we're doing console.write right there, which we shouldn't do, and then we're going to delegate that off to prompt.write or print. What am I doing wrong? Printer.print.
I was like, prompt's just a string. I don't think you're going to find that.
Could make an extension method on string.
This is true.
That would be awful design. But at this point, because we registered it differently, this does actually affect some other piece of code, which happens to be this right here.
Mm-hmm.
And this is why this is generally not preferred, but it is when we inject properties and other things that aren't types, which we'll see soon. So now, in order to resolve the iTextPrinter dependency, we can use that handy context method, or context parameter that was passed in as part of the delegate. And we can just use resolve, and we can say resolve iTextPrinter. So obviously it's a lot more code, and we see that it works just as it did before. Yeah, obviously it's a lot more code. I'm trying to think of a... Here we go, we can do this. This is actually a good example. We're going to turn our text getter into a singleton. So we can no longer depend on anything, because that's one of the drawbacks of the singleton pattern. But he's still going to have this interface, and he's still going to get text. And then we're going to do the whole singleton private static console text getter instance public static console text getter instance return instance or new console text getter. And what doesn't ReSharper like about that? I don't know. Oh, right. It's just reminding me that I was being dumb. Okay, so now we've turned console text getter into an interface, which presents us with a problem because we can no longer inject him using the register type. If we attempted to do the register type, this is what would happen. If we attempted to do console text getter as an iText getter, this will compile just fine because it's syntactically valid. We'll just get a nice little exception saying that no constructors on type console text getter can be found with public binding flags, meaning it can't find any public constructor because by definition singletons have private constructors, so we can't instantiate them. So that's one of the reasons why I don't like singletons, but Autofact gives us a really nice way to get around that, where we can register singletons using the register overload. And now we can just do console text getter dot instance and then run it. And the first thing we'll get is a prompt from the console text printer, and then we'll get that.
Cool.
So, Zach?
Yes?
Did you say hi, Nelson?
Yeah, I said, did he say, hey, Zach?
Yeah, just hey,
Hey.
that's what I said. Just say hey, Nelson.
Hi, Nelson.
Yeah. So how you doing so far?
I'm all right. Keep rolling.
Okay. So the next issue is how do we control the lifetime of our objects? And I'm going to we're gonna do another service. We're gonna have an iDatabase session. He's not gonna have anything on him, because we're just using him for demonstration purposes. But normally he would have things like save, load, update, query, and all that stuff.
Mm-hmm.
And then we're going to have a database session class, which implements iDatabase session. And the only obviously we don't have any contract to fulfill, but we're going to go ahead and write a constructor. Spaces. That says,
I was created.
if I can get the formatting to work right. Actually, we're going to do this for all of our objects, just because. Just get a better feel for how these are injected.
Mm-hmm.
And then our console text getter will have a plus console text getter, and then our controller will have a plus bar controller, and then so I don't have to type in text every time I'm going to nuke that line of code. Okay, so now we have our database session, our iDatabase session, and it's been determined that our controller needs to have a dependency on the iDatabase session for some reason. So he now takes in an iDatabase session as a parameter. And then we do, let's go ahead and just register him. Register type. Database session as iDatabase session. And then we are actually going to do this twice. We're going to get two controllers for this request. Or how about this simulates, this is actually going to be two web requests if we're thinking in terms of ASP.NET. These are two requests that come in from the browser.
Mm-hmm.
Is everyone okay with that?
Yep, absolutely.
So now when we run, we'll now see how Autofact creates all of our stuff. So on the first request, we create a console printer. And you'll notice that's because the bar controller, the first dependency is an iText printer. iText printer is fulfilled by console printer, so this line of code gets executed. The next line of code is our console text getter, which ultimately just does this right there, which we've already talked about. And then the third one is the database session, which is implemented by this guy, our database session. And then our bar controller finally gets instantiated, because remember, these are all things that he depends on. Right. He needs to get instantiated last. Then he does his thing and returns.
Mm-hmm.
And now the only reason we don't see the same thing here, we don't have a console text getter. Do you know why that would be, Zach?
No.
Well, if you look at our registration, our console text getter is being registered as a reference to a singleton. So the next time someone wants an iText getter, this same line of code gets executed, but because of the way we put together our singleton,
it just hands out that already created instance.
right?
So the first time it's hit, of course, it needs to be instantiated, which is what you're seeing up there. That's but then the second time, it just hands it back out.
Mm-hmm.
Yep. So yeah, so that's the first thing. So you'll notice that's how everything gets constructed. But what if we decide that our console printer should now be a singleton? We only need one of them. Just do .SingleInstance.
And this is what Nelson was saying back over in Nelson's corner, why he hates singletons and he prefers to have IOC containers managed for him and give him singletons in this fashion.
Exactly. It's just so much easier, and we can decide whether or not we really want him to be a singleton and all that stuff. So then, and then he gets injected just like normal, and we see that our console printer is now only instantiated once and then reused for everything else.
Mm-hmm.
So our database session is being instantiated correctly. Remember, we want one session, database session per request. I'm just gonna keep it there. Console printer is gonna be singleton, so we have a database session.
Do you want to go ahead and unify the manner in which you're creating the singleton so you're not using two different methods? Because aren't you?
Yeah, this accomplishes the same thing, but it also shows two. But yeah, I guess we already talked about it.
Yeah, since you showed it, that go along with it,
just for sake of continuity.
Yeah, so let's go ahead and just register type single instance, and if you will recall, this will still fail because our constructor is private.
Right. So now here's the nice thing, though. Now he just treats this as a regular class.
Yep. And now he can accept dependencies, which is another cool thing, because previously with the instance method, he couldn't accept dependencies. Once you get into static land, it's so difficult to get back out, which is another reason why I dislike it. Because now in this case, we can just write a list of dependencies, and Autofac will just give them to him.
Yeah, and it's actually kind of cool to see everything come full circle around to why you didn't like using singletons when there's an option like this anyway.
Yep. So yeah, so now we have two singletons, and we have our database session. The database session is being, that's working out cool, but there's a problem with it, and I'll demonstrate the problem. I'll demonstrate the problem by making the console. No, I'm just gonna make another. I'm gonna make another one.
Strike two.
We're gonna have an iUser repository, and then we're gonna make a user. User's not gonna have anything on him. It doesn't matter. It's just for demonstration purposes. And our iUser repository has one method that returns a list of all users. Get all users. And then now we can create a concrete implementation of our iUser repository called user repository. And he implements iUser repository with the single method that's just going to return null. I don't really care what he returns right now. And then our iUser repository obviously depends on an iDatabase session because he needs to get data out of a database. So that's cool. So let's go ahead and register our iUser repository. Tell Autofac about it. So builder.register type user repository as iUser repository. And then, no, I don't want him as a single instance. So that's cool. So let's go ahead and use a user repository in our bar controller. So now our bar controller is getting pretty large. This is more or less an anti-pattern, having so many dependencies, but remember this is just for demonstration purposes. Actually, you know what I'm going to do?
You're going to actually use it.
Yeah, it turns out that I'm going to use it. I lied. And it also turns out that I'm going to put a property on user as well.
Yay.
So I lied about two things.
That's alright.
N creates a little auto property up on the user class.
You didn't lie, you're just making further developments.
And then our get all users is going to return a list of a few users.
I wonder what Nelson's going to name his kids.
Yeah, I know.
Whoa! Yes, Daddy?
Yeah. Blah.
Yeah. Get over there near blah. Okay, continue.
Oh, Zach, you didn't remind me. You weren't paying attention.
I guess not.
I need to add that as well, just so we can demonstrate when it's actually instantiated. So now we have an issue. Remember how you only want one database session per request?
Mm-hmm.
We now have two objects that are asking for an iDatabase session. We have both the user repository wants an iDatabase session, and the bar controller wants an iDatabase session. So what does NHibernate do when it's presented with this? You'll see that two database sessions are instantiated.
Okay.
Well, that's obviously not what we want.
Mm-hmm.
Because we want each session to share the same database, each request to share the same database session, so for all obvious reasons, performance being one of them. So in order to do that, Autofac has introduced the ability to define lifetime scopes, and lifetime scopes are really awesome, where lifetime scopes are disposable, just like the container. And we'll call this lifetime scope request 1, and he's going to be assigned to container.begin lifetime scope. And then we're going to put all of our code in here, or all of our first request in this one lifetime scope. And then we're going to put all of the second request in this second lifetime scope. So the lifetime scopes allow us to delineate our code, or our client code of Autofac into little places that have meaning, little containers, little sub-containers, I guess you could call them. And when we resolve, we're not going to be resolving on the container anymore. We're going to be resolving on the individual request lifetimes that we want. So now if we run this again, we'll see the exact same thing, because we haven't told it to really do anything differently. We've just delineated the two requests. But now what we can do is go into our registration for our database session, and we can tell it to instance per dependencies default, which instantiates it every single time that it's asked for, then instance per lifetime scope. And what this does is you'll notice that database session was only created once for this request, and then database session was only created once for this request. So what has happened is that these two lifetime scopes both have their own little database session that it's constantly being passed around to everyone. And then you'll notice, remember how we talked about disposable stuff?
Mm-hmm.
Sessions are a great example of something that needs to be disposed because they need to close their connection to the database. In order to use disposable stuff with Autofac, it's actually pretty straightforward. You just implement iDisposable, and then add your dispose method. And we're going to do minus database session.
Makes sense.
So now our database session is being is marked as disposable. Disposable, remember, doesn't add any special functionality as far as .NET's concerned. But Autofact picks up on the fact that it's disposable, and when the lifetime scope that owns it gets disposed of, it'll also dispose all of the objects that it holds a value to. So now you see our database session is being disposed of properly at the end of every lifetime scope. And remember that all the using is doing is calling request1.dispose at the end of it.
Right. So now just both those requests are using the same session.
Right. And then at the end of it, it's all being gotten rid of properly.
Cool.
So here's kind of an interesting problem. Our database session, we're registering type like that, where our database session is just being instantiated. But like we saw with working with NHibernate, this really isn't how it works. What we have in NHibernate is we have a session factory, and then the session factory opens up database sessions. Now we've talked about Autofac enough to where you should be able to implement this yourself, but I'm just going to go ahead and do it right here. So we'll just call this, and we'll create another interface called iDatabase Session Factory. And it'll have one method on it called iDatabase Session Open Session. And then we'll go ahead and create an implementation called Database Session Factory, implementing iDatabase Session Factory. And this could be like an Hibernate Database Session Factory. For example, in the constructor right here, we could initialize our configuration object, for example. Alrighty, so now we have our open session. Our open session is going to return a new database session. And obviously right here, it would we would compose an Hibernate session factory, and we would call factory.openSession. But right now we're just cheating and returning a new database session. So now how do we wire this up with Autofac?
I don't know.
No, I'm actually just asking a rhetorical question.
I know, I'm just being silly, sorry.
Enough of that.
Yes, sir.
Okay, so now we have a slightly more complicated thing that we need to wire up to Autofac. So the first step is going to be, we need to register our database session factory as an iDatabase session factory. And then we need to register, and then we need to tell it single instance, because remember in MVC or in Hibernate, we'll only ever want to create one configuration object in one session factory. So we want this to be Singleton essentially. But obviously our database sessions aren't going to be Singletons. They need to be in the context of a lifetime scope. Now, unfortunately, right now we can't just do register type database session because we want to get our database session through a method that's only available on our iDatabase session factory. So we can use the awesome register method and do this. We can do context.resolve iDatabase session factory open session. And then we can say instance per lifetime scope, or let's just do as first, as iDatabase session, instance per lifetime scope. And resharp are done like that. There we go. And so now we can run this, and actually, hold on. You've probably already seen it. Notice that we never instantiate a database session factory anywhere. Nobody knows about it. They don't care about the database session factory. The user repository, for example, only cares about a database session. But we've sufficiently told our Autofac enough about our data model or our object model that it knows how to ask the database session factory for a session. So if you see how everything works, you'll see that our iDatabase session factory gets instantiated right there. Then he opens the session. Then the session gets closed. Then he opens up another session. Then that session gets closed. So you see how he's only instantiated once because he's a singleton, and then the sessions only get instantiated during their individual requests.
And that's just absolutely awesome.
Yeah, it is.
Oh, yeah. Okay, so, yeah, let's kick it up a notch. Check this out. This is something else that we're going to be doing a lot of in the stuff, in the
stuff and things. Yeah.
Yeah, and the stuff and things
in the future.
There you go. We don't want to. Our repository. This is a prime example of something that is annoying to write out because then we'll have an user repository, and we will in our code because we're not using active record type stuff. We're doing more, better stuff. But if we wanted to genericize our repository code to the point where we only have one abstract repository, and he takes in a type of T entity, and he returns an IEnumerable of T entity with his get all entities, and then we only wanted to create a one repository. So we don't care about user repository anymore. There's no more user repository. there's just a generic repository. So we'll just call him repository. And he's generic. And he implements iRepository of type tEntity, which is the parameter that's going to be passed in on the code that instantiates him. And then we're going to go ahead and implement a single member, which is getAllEntities. I'm actually going to cheat here. Under normal circumstances, this is what you would do. You would take in an iDatabase session. And then you would say something like return session.query tEntity, like that. And then toList, because we're returning an IEnumerable.
Mm-hmm.
So this is what we would normally do. Unfortunately, we don't have our iDatabase session being that smart at this point. So I'm just going to cheat. I'm going to say if type if type of tEntity equals or no, not type of, or yes, type of. I don't know what I'm thinking. If type of entity equals user, then return. We're going to cast it into a tEntity type. New. This is going to look a bit funky. I'm just, like I said before, I'm cheating right here. I'm just short-circuiting this sort of. And then we'll just return null, which won't work. We'll just return a default. Oh, no, we can return null. Never mind. Oh, yeah, that won't work either. We're going to have to do as tEntity. There we go. That works. That looks funky. Don't ignore this line. This line doesn't exist. We're just using it to simulate what would happen if we deferred it to our database session, if database session was an actual, and Hibernate iSession. So at this point, we now have our iUser repository, and we don't have our iUser repository. It's now gone. We just have the iRepository of type user is now what we have, and what we have to work with. And then it's no longer getAllUsers, it's getAllEntities, and you see that everything compiles just as it did before. Well, no, except with the exception of our configuration code. But do you kind of see where I'm going with that, Zach?
Yeah, I think so.
Basically, when I ask for an iRepository of users, I want Autofact to say, hey, I know how to make an iRepository. I'm going to create this repository, and then I'm going to pass in the user generic argument into this type. And then it's just going to work as normal. We only want to write one repository for every single type of entity, but we want to use it in a strongly typed fashion using the of type user.
So you could have like a repository of users, a repository of addresses, or whatever else you might need.
Yep, and it would work just all the same. So now at this point, our user repository is now broken. We now have to register. But what's interesting is we can't register the a generic type using normal syntax. What we have to do is we have to say register generic. And then we have to pass in a type. And this type is going to look a bit funky, but we already talked about this particular syntax. We're passing in a type of iRepository with blank type arguments. And remember that this is the only instance where this syntax is valid. Under normal circumstances, this would throw an exception or a compiler error because we're not passing in any argument into the tEntity parameter. But in this case, when we're using type of, this is valid. This returns a special type object that kind of talks about the iRepository and says, okay, well, we have an iRepository class. It does stuff. It has these members, but it has this generic argument. You're going to have to supply if you ever want to use it. So then we'll say as, and we'll pass in, or as, and we have to do this because we can't do it with the curlies. Type of or wait a sec, way to pay attention, guys. We're passing in our component first, our repository.
It's just the lag, dude.
Yeah, I'm sure. I'm positive, though, about that. But anyway, so now we're registering generic repository as an iRepository. So this looks really funky, but basically all we're doing is we're saying, Autofact, whenever someone asks for an iRepository of type whatever, give it a repository of type whatever.
Yeah.
And you'll notice that if we run this, it will just work normal. We see our hey there right there. Because our special... actually, hold on. Let me make this a little bit better. On our repository... let's do a let's do this with that plus type of t entity. So you see that our repository of type user was indeed instantiated on both requests. And then if we, at any point, like for example, let's just add another dependency on this bar controller. If we ever asked for an iRepository type string, we'll see that we now have two repositories instantiated, one for user and one for string.
Cool.
Yeah. Do you have any comments, maybe something I left out or anything, Jason?
No, I think this is probably the best overview that you've given of both Autofact and just the whole IOC container idea.
I think it's a great follow-up for our last video.
Yeah, this is. I thought it was beautiful.
Well, there are a few things I can. I mean, how much more content could I possibly stuff in people's brains before they start freaking out?
I think at 56 minutes it might be a good time to let people get a sip of water and then maybe try the next video. You know what I'm saying?
I mean, do you feel like you've pretty much? I mean, you've covered registered, register type, registered generic. Do you think you're pretty good for as far as what we're going to need as we implement the actual foundation of our application?
Well, there are, as far as the syntax and what we'll be using, this will be pretty much all we're going to be using initially. But there are some weird sort of things that I want to do with Autofac.
Okay.
That that would be good. Maybe, do you want to do that in another video or this video?
How long are you thinking?
Not very long.
Go ahead and do it now.
Yeah.
Let's go and do it now.
We'll try.
Just so it's all self-contained.
Okay. So everything's getting messy. I'm gonna go ahead and say move types into matching files. That was Control-Shift-R, just to clean things up just a little bit, because I'm not going to be using any of these things anymore. I still want them to exist. I still want the output.
Right.
I just don't want to deal with them anymore in the same file. And then I'm going to create a abstract folder and dump all of our services in there. And then we might as well just do this as well, components. One more. There we go. So now people can refer over there to see kind of like the structure of what we made. But something weird that I'm going to be doing with our project is I'm going to be introducing the concept of extensibility points into it. And like I said previously, it's going to use all the same stuff that we've already talked about. I just lied. It's going to use one more thing that we haven't talked about. But we could conceivably make it work with everything we talked about. It's just a shorthand. But so what we're gonna do is we're gonna create an iHook interface, and he's gonna be blank. Then we're gonna have an iFramework or an iHook handler, and he's gonna be a generic interface with a tHook, and he's gonna have a void handle tHook hook. And then we're going to have an iHook dispatcher, and he's going to have a void dispatch tHook hook. And then we're going to have type constraints on all of these, specifying that we can only pass in things of where tHook is an iHook. So tHook kind of just acts as a tag, I guess you could say, this, or iHook acts as a tag for our objects, so that we, when we pass objects around here, we know that we're only dealing with things that have been tagged with iHook. So basically, our use case for this is going to be something like this. Our use case is going to be, we're going to want to build a dispatcher, and he's going to be container.resolve iFramework or iHook dispatcher. And then we're going to want to create some little classes, some little hook classes, like how about request start hook, which implements iHook. And then we're going to have a request end hook that implements iHook. And then at the beginning and ending of each request, we're going to do dispatcher.dispatch new request start hook, and then a new request end hook. And then we're going to do it like that. So at this point, we now have to write a implementation for our iHook dispatcher. And the expected result of what I want to happen is I want any class that's in our project that implements the iHook handler of type request start hook. I want all of those classes to be run right here. And then I want all those classes to be instantiated and run right there for the end hook one. And I'll show you what I mean by that. I want to be able to create a class anywhere in the project called stuff. It doesn't matter what the type is or what the name or what it really does at all. It just implements the iHook handler of type request start hook. And he has to implement, obviously he has to implement the handle method.
Mm-hmm.
And he's going to say request started. He's actually going to implement both hooks. He's going to have an iHook handler of request end hook. And then he's going to say console.write line ended. So I could have as many of these guys as I want, as many classes that implement these interfaces. And whenever the start hook gets dispatched, I want all of those classes to be run and instantiated, and I want their specific handle method to be called. So do you understand the expected behavior, Zach?
Sort of.
When this line happens right here,
yeah.
dispatch new request start hook.
We should get started.
Right,
yeah.
Because I want Autofact to look in my entire assembly, find everybody that implements this interface, and then invokes this method for every single class. So to write our dispatcher class, he's going to have a dependency on our lifetime container because he needs to instantiate objects. So he needs to have a reference to Autofact, essentially, but we don't want to resort to static things. So we're going to request an iLifetime scope, which we're going to... Yeah, okay, we're going to inject later on. It's going to look a little bit funky, though. So basically our dispatch is going to say var services equals scope resolve IEnumerable of iFrame or iHook handler of type tHook. And then we need to import our system collections generic. And then we're going to want to for each over and then we're going to want to call service.handle, and then we're going to pass in our hook. So yeah, so this basically says Autofact, give me a list, IEnumerable, of all interfaces that, or all services that implement this thing right here. And IEnumerable is something picked up automatically by Autofact. It's not going to literally return an IEnumerable that's been injected. It's going to actually, it has special behavior that happens when we ask for stuff that is IEnumerable, which is really neat because now we can return all of the services that implement, or all of the components that implement the service. So at this point, that's all set up. But unfortunately, you see that we have our iLifetime scope, and he's not being injected anywhere, which is kind of difficult because we're instantiating our lifetime scopes down there. So what I'm going to do is I'm going to do something a little bit funky. I'm going to, no, this is going to look ugly, I know. This is what I was groaning about earlier. We're going to make an iLifetime scope in the scope of everything. So we'll call them scope. And then instead of I'm going to put them up here in program. iLifetime scope, get set. And then we're going to do builder register context scoop as lifetime scope. And then it doesn't like this because it's not static. Just ignore this particular part right now. Pretend that I'm not doing this because it's particularly nasty, and it's going to look a lot nicer once we start working with ASP.NET. But now our iLifetime scope is being injected, so our hook dispatcher now has a reference to it properly. So now we have to register our hook dispatcher. Register type frame hook dispatcher as iHook dispatcher, and we want him in single instance because he doesn't need any reason not to be a singleton, or doesn't have any reason not to be a singleton. And if we run this, we won't get any errors, hopefully, but we won't get our expected output. We do get an error. Return null. Oh, yeah, it's not going to work. We need to stupid. Yeah, I know exactly what I'm doing wrong right now, which makes it... Okay, we're going to instantiate our dispatcher on every request, and this is getting more convoluted, and I know. I apologize.
No worries.
He's not going to be a single instance because he needs a new reference to a iLifetime scope during each request. And now we're going to run it. Now we're not going to get any errors, but we won't get our expected output. We don't see that output anywhere from our dispatcher, but we know our dispatcher is being called because if I put a breakpoint right here and step forward, you'll see our services gets returned, but it's empty. And the reason it's empty is because we're using IOC to retrieve our hook listeners, for example, our stuff, our hook handler. But because we're using IOC to retrieve him, he needs to be registered with Autofac for him to show up. But we don't want to specify all of our hooks as part of the builder container thingy. So we want to build a little convention. We want to say stuff hook. And so his name ends with hook. And then we're going to instruct Autofac to register assembly types. And then we're going to pass in an assembly, so it's going to be type of program, our current thing. And then we're just passing assembly. So this is going to be the current assembly, or the only assembly in this entire application. And we're going to do .where. So this basically where will be... This isn't the link where, this is the Autofac's where, and this where will be called for every single type that he finds in whatever assemblies we passed in this case program. And then we're going to say where type name ends with hook as implemented interfaces, which is just shorthand for doing as, and then every single type that this interface implements. But because we don't know beforehand what types this type implements, we have to do this one. And then we end that, and it's good. So basically this is telling Autofac to search our entire assembly, find types that ends with hook, register them as implemented interfaces, which in this case will only match our stuff hook, register him as these guys, which will in turn have him show up in Autofac right here when we try to resolve him. And if I run, we'll see we have our started, ended, started, ended. That wasn't as concise or clear as I was envisioning it to be.
It's the story of my life.
That's okay. I mean, I think if somebody watches up to here, and if they're confused on it and they back up and watch it again, I think they'll be good. Plus, we're going to be using this again very soon, and it's going to be a lot less wired in the way that you're just trying to kind of shoehorn it in to work at the moment. Right. Which will be helpful. So yeah.
All right, sweet. So yeah, I'm done talking.
Okay.
I should have listened initially.
No, it's all good.
No, this is good because you're going to be using that soon
Yeah.
enough anyways, because that's going to be extremely helpful. So yeah, this is an outstanding review pretty much of Autofac, as we're going to be using everything that Nelson has just laid out in front of you in this video with the new foundation that we're going to be putting together for our application. So with that, if there's anything else you want to add, Nelson?
No.
Okay, Zach?
No.
All right, well, that's going to wrap up this video. Thanks a lot, everyone, and we're out of here.